If the nozzle spray's fine, it's working just fine, correct? Would you guys say that? That's true? Correct. It's not true. Why?
Well, because two things, your gallon per minute, you're gonna save water and chemicals.
Yeah.
Two, is the pressure right, is the pattern right to actually clean the car?
Yep.
That's what the customer cares about.
Correct.
So that's what I thought, you know, I'm here.
Yeah, no, you're going on the right path. So yeah, let's talk a little bit about that. Just by looking at these two nozzles, just this video, these two pictures and these two things, could you tell which one's worn or not?
Which one's worn?
Yeah.
On the bottom, the left one's worn. On the top, I'd say the right one's worn.
Correct. But if you were to just look at this two pictures, you wouldn't be able to tell, correct?
No,
yeah. So this one actually is worn 30% over nominal flow rate, like you'd mentioned. And the reason I bring that up is usually you will not be able to tell with your naked eye. So you want to maintain your nozzles. You want to check your flow rates on a monthly, maybe weekly basis. I would definitely say at least every 2 to 3 months for sure, just to make sure your costs are under control. Just because you can't really see, you know, we've got equipment that can actually graph this data for us. You can see over here. And then we've got the microscopes that can actually look at the orifices for you guys. But yeah, so that's why I bring that up. Like 30% nominal flow rate, you can't really see anything in the spray itself. You're gonna see a perfectly looking spray, but the performance of it is going to be really, really different.
On a stainless steel nozzle, is there a rule of thumb for like how many hours before they start to get that major wear?
It honestly depends on the operation and what stage it is at.
So if you check a gallon per minute, what range should you be in comparison to what's that rated at?
I would say somewhere between 10 to 20% increase is going to be your target, because then you would, as you'll see later on in the video or then the presentation, there's going to be a lot of cost that you're going to be taking on over.
Okay.
So a little bit about the IMEG versus the WashJets.
My apologies.
Yeah, that's all right. The IMEGs are specially designed, like I talked about earlier, to deliver more impact while keeping the lower flow rate and the lower pressure. So it's going to take away a little bit from your pumping costs as well. With the lower pressure, lower flow rate, it delivers the same impact. And yeah, so you can see here, this is going just diagonally over your spray, and this is going laterally across it. So you can see, you know, the MEGs has the heavier edges and like a pretty uniform center, whereas the IMEG has pretty uniform distribution all over. And it also has much, much higher impact force. So yeah, I think it's about 25% more impact. So in order to cut down a little bit on your pumping costs, you could consider switching to an IMEG. All right, now let me ask you guys this. I have here the nozzles don't perform correctly because of the erosion, damage, or obstructed nozzle orifices. Can you guys think of anything else that could affect the nozzle performance?
Plugging from the rear.
That would be your obstructed nozzle orifice. Anything else? What about when there's sediment that's caked on the nozzle? That would be one, correct? Then you've got corrosion that, like I talked about, we have chemically resistant materials available because of corrosion. So that would be another one. Accidental damage for you guys that have the self-serve car washes, right? People drag and drop in the nozzles. That would be another one. It would kind of go hand in hand with the obstructed nozzle tips. All right, let's talk a little bit about erosion. What is erosion really? That's typically what I would say when your gallons per minute or your flow rate goes up. Why does that happen? You're moving material from the nozzle itself. Just because of the operation. It just causes the internal orifices and the flow passages to enlarge or get distorted. The effects of that would be your flow rates would increase, pressures would generally decrease, the overall system pressure would decrease, so then you have to run the pump at a higher pressure to get that same coverage. The spray pattern would become irregular, and then your drop sizes would increase. And like I talked about earlier, it's going to be the chemicals or the outside factors are going to be attacking your nozzles, whereas erosion is going to erode away that internal flow passages. This is going to be on the outside of the nozzle, like you can see over here. This would also cause the same irregularities as erosion, which is why it usually gets confused. In order to solve this issue, you would have to work with your material suppliers or your chemical material suppliers to choose the right nozzle material. So, some chemicals are not really compatible with either stainless or brass or both of them. And so you'd want to choose your plastic nozzle, which would be the Kleen-Rite nozzles, or your polypropylene nozzles, which would be much more chemically compatible with a whole lot of chemicals. Caking and bearding would be just stuff getting caked up on the outside, blocking the nozzle orifice, preventing the spray or the spray pattern to fully develop, which would also affect your cleaning efficiency. And your customers are definitely going to see that, and they'll be like, okay, what's going on? They're not really maintaining their car wash, correct? So another way to kind of get rid of this problem is regular maintenance, regular cleaning. Accidental damage usually happens when there's a damage to the nozzle orifice or it's not installed correctly. This would, for your self-service, this would be like someone's dragging the nozzle on the ground or it's being dropped too many times, or some accidental damage on the plastic nozzles would be you're stripping your threads or you're cleaning the nozzles with, like, I've seen like metal wire brushes. Clogging the nozzles would be just restricting the flow because of lack of strainers, or there's something that was strained, got downstream of that path or that liquid path. You can get rid of this by regularly cleaning your nozzles or your orifices. Improper assembly, this is the biggest one. When you take the nozzle out of your process, you want to make sure not only is it disassembled correctly, but you want to make sure it's reassembled properly. The gaskets, the O-rings, they're in place. They're not blocking anything. Otherwise, you're going to see leaks. You also want to make sure you're not over tightening the nozzle caps to the bodies. Otherwise, that's also going to cause your leaks because of thread stripping. Detecting nozzle problems. When I say that, your flat spray nozzles, they're going to have a super heavy, either super heavy center or super heavy edges. That's going to decrease your coverage as well as your overall spray angle. The solid streams are not going to be a glass rod. It's not going to be a straight line. It's going to be having dribbles in there. And then the full cone spray pattern would just not look uniform. So a little bit about nozzle maintenance. You want to regularly inspect and clean them. You want to have a maintenance schedule developed. Most importantly, you want to monitor your flow rates and your nozzle appearance, as well as monitor your entire system.
So with flow rates, self-serve, for example, is that simply turning on the high pressure pump, putting a 5-gallon bucket, running a stopwatch, and like measuring?
We'll get into that, yeah. But essentially, it's kind of the same idea, but I've got a few other options that you guys could use as well. So cleaning the nozzles, you want to make sure whatever you're using is much, much softer than the nozzle material. Never ever use steel brush, please. But plastic nozzles, you want to make sure you're not opening up that orifice or blocking that orifice with anything. Since the orifices are precisely engineered, we just want to make sure you take utmost care of it. Tips to prevent spray component plug-in. You just want to make sure with this is you've got your filters. Nothing's going downstream of your filter after it's been filtered out. You want to make sure there's no pipe compound or pipe seal tape threads. They're also going inside, which would plug up your nozzle orifices. All right, so a little bit about detecting flow rate changes. For any given pressure, we usually rate these nozzles at 40 psi in our catalogs. And we've got various other different pressures, which will give you the flow rates on those as well. So you don't necessarily have to test it at 40, but for any given pressure, your flow rate will increase as the surface of that orifice area has been increased. If you're using a positive displacement pump, your system pressure is going to decrease. Your flow rate will remain constant because it's a positive displacement. It's going to just deliver that same amount of flow. And you're going to have a decreased cleaning performance. With the centrifugal pumps, your system pressure is going to remain constant, but your flow rate will increase. So the pump's going to go into overdrive, basically. And you're going to have increased water and chemical usage, which would also increase your operating costs. For your worn nozzles, or to detect your worn nozzles, I would say test 1 or 2 nozzles from each stage. Mark those for future tests. You want to make sure you're using the same nozzle, not different nozzles. You want to compare that with our catalog data, either at 40 psi or any other psi that's listed on the catalog. You want to repeat the test throughout the year, and you just want to keep a log of that result to see where and how much you're wearing by. So how can you inspect it, right? How can you tell when there's an increase in flow rate, when there's a damage, or when you've got a worn nozzle? So this is what, similar to like you'd said, like the old school method would be, you've got a certain pressure on the pump, you hook up the nozzle, you spray it into a bucket for a minute or 2, then you transfer that volume over to a graduated cylinder or a flask or something, and then you just divide volume over time to get your flow rate. Then the second option would be to get a 5-gallon bucket, pressurize it, use a pump to pump it at 40 psi, or use a pressure gauge or a spray valve so that you know what the pressure you're operating at. Spray it and then measure the flow that way using a graduate cylinder, or you could have a flow meter that would tell you what the flow rate is. Another idea that we use, this spray tank here is actually what our sales offices use. Spray tank with a pump, possibly a regulated pressure gauge, and an integrated flow meter, which you can see over here, that's going to tell you your flow rates. So then how do you record your results? Once you've got all of that, you want to make sure you have a log of all of the flow rates throughout the year, or however you do it. After about 10 to 20% flow rate increase, we usually recommend that you switch out the nozzle, just because that's going to keep your operating costs under control. What is the cost of a worn nozzle? So here we'll go a little bit about the assumptions I'm making here. It's going to be about, your average cost of water is going to be $2.50 per 1,000 gallons. Average cost of your chemical or detergent is going to be $10 per gallon. The dilution ratio is going to be 40:1 water to chemical. Chemical usage is 35%, and the nozzle is worn just 15%. So right in the middle of where we say you need to change it out. Doing all the math for the conveyor wash, you're going to waste about $23,000 or $23,600 per year, just in access wastage costs only. If you have an in-bay automatic, you're going to lose about close to $12,000 every year. Yeah. And I believe, on the Spraying Systems Company website, we have multitudes of different resources where we have nozzle wear calculator. We've got our catalogs that are listed with the different pressures and different flow rates at those pressures. Here's the nozzle wear calculator. You can also find the nozzles online, so you can quickly order those. We've got many articles on tips about how to save in your processes for you as well. And I think that should be it for us today. Thank you for sticking around. Appreciate that. Thank you, guys.